Once again, you are welcome to Wisdom Academy. Today we'll be looking at science. This is rocks and weathering. So we're going to look at rocks first, and then we look at weathering, what weathering is all about. Okay. So we describe rocks and the types of rocks and the example of each types, and then we talk about weathering, how it leads to formation of soil, how weathering of rocks helps to form soil. So let's talk about rocks as quickly as we can and look in the different types of rocks that we have, and then we'll be able to move forward. Rocks are very important to us, to human beings. We need rocks so much. We break rocks to build houses. We use them for so many different things. Okay, we use them as stones. We use them as building blocks for houses. Now, the surface of the earth that we live on is made up of different rocks. The surface of the earth is made up of rocks. Some houses are actually built with rocks. Okay, so we're telling you the advantage, the benefits, the significance of rocks, the good things from rocks. And most importantly, the soil that plants grow in is made from broken down rocks. The soil where we plant things are actually made from broken down rocks. So you can see the plants will not have a place to germinate or to grow without rocks. Rocks were broken down to form soil. Without soil, rocks were broken down to form soil, and these soils are used. So without soil, plants could not survive, and animals and human beings will have nothing to eat if there are no plants. So you can see the relativity. So rocks break down to form soil, right? Rocks break down to form soil. Now this soil is where our plants grow. These plants, animal feeds on them. Okay, when we say animal, we include human beings. So animals, they feed on these plants. So the plants and animals, they are our food. Without food, we cannot survive. So you see, without food, we cannot survive. And without, you see the chain of reaction. The rocks, they break down. To form soil, they have to break down. They have to break down to form soil. Break down. The rocks break down to form soil. Okay, the soil is where the plants can grow, germinate and grow. And when that happens, they make fruits, and that fruits and food is what the animals eat. And then we human beings, we eat both the plants and the animals as food, and we survive. So you can see soil is super important. So, but this is not only the characterization of rocks. We can also give it another concept from the fact that we say rocks are used have other uses, like for building houses. Okay, for building houses. For building houses. And then we can also use rocks for find other applications with them, right? Stones, making stones. Rocks for making stones. Gravels. For making gravels. So you can see there's so many uses of rock, okay? So all of this we have showed diagrammatically how these uses applies, okay? But not only these advantages or benefits that we get from rocks, there are other things that are super important, like the minerals. We're going to talk about the minerals that we get from rock. But what are rocks first and foremost? Most rocks are mixtures of mineral, right? So these rocks are mixtures of mineral. So when we say rocks, what are they? And we say rocks are mixtures of mineral. Mixtures of minerals. Rocks are mixtures of minerals, okay, where that we can exploit to our advantage. We can exploit to our advantage to build our environment and to build our countries. Minerals are substances that occur naturally in the ground, right? They are natural substances that occur on the ground. Some minerals are elements. Okay, you study elements in chemistry. Some minerals are elements. Others are inorganic compounds. So these minerals are made up of two things. They could be elements. The minerals that are found inside the ground, they could be elements, and they could be what? They could also be what? Inorganic compounds. They could also be inorganic compounds. Organic compounds could be things like glucose, okay, when we say organic compounds. Inorganic compounds are things that are not manufactured, they are naturally found, okay? So we say they could be, some of the minerals could be elements, or that could be inorganic compounds. Most minerals, they are solids and they form crystal shapes. So most minerals, they're solids. Most minerals that we found in nature, most of them are solid. It's not like we don't have liquid minerals, but just that most of them are solid, mostly solid. Most of the minerals are solid, and they have what? They form what we call crystal shape. Crystal shape. Most minerals are solids and they form crystal shape. Now let's begin to give examples of minerals. Can we give examples of minerals so that we know exactly what we're talking about? You see that you know minerals. You know minerals. Number one, diamond. You know, we find diamond underground. We dig them. We have a lot of them in South Africa. A lot of diamond in Africa. Okay? So, diamond. Now you know. Let's give more examples. Let's give more examples of minerals. Gold. You've heard of gold. See, some countries, they have gold. A lot of African countries also have gold. Okay, and some Arab countries, they do have gold. Okay, so we have gold. These are solid minerals. We're talking about the solid minerals now. So these are work. When you have minerals, because these minerals are found in the rocks. Okay, when you have minerals, you're wealthy. When you have minerals, you're wealthy. Okay, we have gold, we have copper. Okay, we have copper. Okay, you know what copper is used for? You can use it to make copper wire for electrical conduction and conductivity. You can use it to make other metal. Okay, we have copper. So if you have copper as a country, you're a rich country if you use your wealth genuinely. So not only copper, most of the metals, okay, most of the metals are found in this way. We have silver. Most of the metal are found like this, right? We have silver, and then we have silver. These are elements that you can find in rocks. All these are elements. Yeah, all these are elements in rock. You can find them inside rock. Elements found in rock. Elements found in rocks. Okay, so these are elements: diamond, gold, copper, silver. All of this, and a lot more. Not only this, okay, not only subjected to this. These are elements that you find that you can find in rocks. Then we have all those like quartz, ruby, sapphire, mica, and calcite, and mineral compound found in rock. These are elements. Now let's talk about compounds, mineral compounds that you can find in rocks. Let's go this way. So we can say here they are elements. This one is elements. This branch, mineral elements that we found in rocks. So on top of mineral we have rocks. Mini rocks is where we find all of this. On top of minerals we have rocks. So meaning when you break rocks, you can find mineral. These minerals, the element part of it are diamond, gold, silver, copper, and so on and so forth. And let's take a look at the ones that are compounds. The minerals in the rocks that are compounds. Let's take a look at minerals in the rocks that are compounds. Compound minerals. Let me use that word. Let's call them compound minerals. Minerals in form of compound. You know the difference between elements and compounds, right? Compound is a combination of two or more elements that are chemically combined together. You know that, right? Compounds are combination of two or more elements that are chemically combined together. Elements are just singular. They're just one thing. Although they're made up of different, so many types of same atoms. Okay, they're made up of so many atoms, but they are same. All the atoms are same. But compound is when element joins together. Like for example, you take hydrogen plus oxygen. Hydrogen now it's an element, although it's made up of two atoms here. So oxygen is also an element made up of two atoms. If they combine together, they form what? They form water. They form water. They form water. This water is a compound. This is a compound. You can say it's a combination of two or more elements. It's a combination of two elements in this regard. So this is a compound. This is a compound. This is a compound. So when we say mineral compounds, you should know what we're saying. Meaning they are made up of more than one element. When we say the mineral compound minerals, it means those minerals that are made up of more than one element. Meaning when you extract these minerals from the ground, you can actually get more than one element from it. You can get more than one thing from it. The oxygen is an element. This is an element. And the hydrogen is also an element. So you should know the difference between mineral elements and mineral compounds. Okay? So when you extract mineral compounds, you can get more elements from it. You can get more than one element from it. That's what we're trying to say. Okay? So now let's list the ones that fall under the mineral compounds. Okay? A good example is quartz. 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 Quartz is an example of a mineral compound. Another example of a mineral compound is ruby. Ruby. Another example of a mineral compound that are found in rocks when you extract the rocks from under the ground. Another one, it's a sapphire. Sapphire. Okay. Another one is mica. These are compounds, okay, that you get from the rocks under the ground. Okay. Another one is calcite. Another one is calcite. All these are compounds that we get from rocks. Meaning each of these compounds, if you break them, you can get more than 1 element from them. So these are mineral compounds found in rocks. So we say mineral compounds in rock. These are mineral compounds. These are mineral compounds. Mineral compounds in rocks. Found in rocks. So we say these are mineral compounds that are found in rocks. Okay? Okay, so that's that for this one. Is that okay? So let's look at what that is. Some rocks, they're made up of large particles. They're made up of large crystals. Some rocks, they're made up of large crystals. And then, which we call the particles, that fit together. Some are made of smaller particles, like grains, with tiny spaces between them. And some are uniform, there's no crystal or grains. Some rocks are rough and sandy, while others are smooth. Some rocks can be many different colors. Okay, so these are things you need to know, like what you can find in rocks. So we say some rocks, they're made up of large particles, which we call the crystals, that can fit together. Okay, while some rocks are rough, they're sandy, while others are. So these are some characteristics or some properties of rocks. Okay, we can say properties. Properties of rocks. One is a crystal, large particle, which we call crystals. Some of them, they have large particles. Some of them have large particles. Some of them are made up of large particles, which we call crystals. Okay, some of the rocks are made up of large particles, which we call crystals, that can fit together. They can fit together. Okay, piece by piece, they can fit together and make a big rock. Some are made of small, tiny particles, with the one we call grains. Some are made up of tiny particles. Tiny particles. Tiny particles. Those one we call grains. Fine, tiny particles, which we call grains. And then another characteristic of rocks. Another characteristic is that some rocks are rough and sandy, while others are smooth. Rough and sandy, some of them. Rough and sandy. There's some as smooth, some are smooth. Then we have some rocks can be of different colors. So number 5, some rocks have different colors. So we just simplify it by saying different colors. Some rocks have,
Some are dull.
yeah, some are dull, some are shiny, different colors. Okay, so that's that regarding describing rocks. Now, when the particles of the rocks they interlock, the rock is normally shiny and it sparkle in the night. When anytime we see that the particles of the rock they interlock, then it means interlock means the rocks will be shiny. Interlock particles of rocks means it's shiny. Interlock particles of rocks. If the particles can interlock together nicely, it means it will be shiny. It means the rock will be shiny. Means the rock will be shiny. So if the rock particles can interlock, it means the rock will be shiny. Okay, and it will sparkle. It will be shiny and sparkle. But what if the particles of the rocks cannot interlock? It will sparkle in the light. Shiny and sparkle in the light. That's what will happen to that type of rock. When the particles only touch at a point, the rock is normally dull and it feels sandy. If the particles touch at a point, they don't interlock, only touch. Particle touch. If the particles of the rock touch at a point without interlocking properly, interlock, you know the meaning of interlock? Like the end of this enters into the beginning of this, they close very well for this one. It means the rock will be shiny and sparkles in the light. When the particles touch at a point without interlocking, they only touch at a point without interlock, then the rocks will be dull. Without interlock, then what happens to the characteristics of the rock? We say this rock will be dull. Will not be shiny, will not be sparkly, will not be reflective in presence of light. So it's normally dull and it will feel sandy or rough when you touch it. Dull or sandy. Or even rough. Okay? Or rough. So this is what will happen. If the particles just only touch at a point, they don't interlock, then the rock is said to be dull or sandy or rough. Okay? Okay, so this is what we want you to take. Rocks like this are called non-crystalline rocks. So we can call this one let's change the color. We call this one non-crystalline. We call this one non-crystalline rocks. They're called non-crystalline rocks. Why these first ones are called crystalline rocks? This one, the one that can interlock. The particle of these rocks The rock whose particle can interlock, they call crystalline rocks. The rock whose particle can interlock together, they call crystalline rock. The rock whose particle only touch, they don't interlock, they call non-crystalline rocks. Okay? So rocks with spaces between the particles are also porous. So any rock that have space between the particles, we call them porous rock. So we say rocks with spaces between we use short form, okay, BTW, between particles, spaces between particles. Rocks with spaces between particles are called, they are porous. We say they are porous. Say they are porous. They are porous. They are porous. If something is porous, it means what? It means water can easily go through it, right? It's porous. When rain beats it, water can go through it. The water can easily enter the spaces or the pores between the particles. So they are porous means that water can easily, let's use the symbol H2O. It means water, H2O, can go through it easily, can enter into it when it rains. Okay, so that's that for this first segment. Now let's take a look at how rocks are formed. You want to know about how rocks are formed? Okay, so let's end this section. Thank you very much. The part 2 will be how rocks are formed. Is that okay?